Okay, Assalamualaikum dan salam sejahtera. Okay, this is IB Chemistry, Chapter 4, Chemical Bonding. So, on this video, I will explain about the hybridization. Okay, but before that, we go to the definition for a few terms. Okay, first, what is meant by atomic orbitals? Okay, also atomic orbitals represents the region or space where there is a high probability of finding an electron. So every element or atoms have their own orbital shapes. Okay, depends on the locations in the predictable. Example, all group 1 element they have s orbital. Example, hydrogen. Okay, hydrogen have 1s2. So hydrogen have s orbital. And remember that this orbital depends on the valence orbital. Okay, valence orbital. Example, carbon. Carbon have 1s2, 2s2, 2p2. This means that, carbon have p orbital. Okay, we just refer on the valence orbital. Okay, so for the s orbital, from previous video, it have sphere shape and p orbital have dumbbell shape. Okay, and this shape shows the high probability to find the electron. So electron always moving and in sphere motion, inside the each orbital. For the p orbital, electron move in dumbbell shape. Electron always moving. Okay, this is the area where it easiest to find the electron. Okay, next, what is mean by the orbital overlap? So orbital overlapping contain a pair of electron with opposite spin. Okay, to overlap, atom must have single electron in their orbital. Okay, so in terms of combine from atom to another atom, to combine the atom to form a molecule or to form a new compound, one atom have to overlap its orbital to another atom's orbital. As example, s orbital. S orbital overlap with p orbital to form a new product or form new compound. So they have to overlap its orbital. But before that, only orbital that have single electron can overlap with another orbital from atom. Okay, uh, okay. So if that orbital have pair of electron, example helium. Helium have 1s2. Okay, 1s. It have pair of electrons, so helium cannot overlap its orbital to another orbital. That is why helium group 18 is more stable. Okay, because helium already have pair of electron. Okay, next, what is hybridization? Okay, hybridization is process mixing orbital and atom to form new set of hybrid orbital. Okay, so during the process of mixing atomic orbital, some atom have formed new set of hybrid orbital. So new set orbital is called hybrid orbital. Example, methane CH4. Okay, in this case, if we refer on the type number of bonding carbon have 4 bonding. 1, 2, 3, 4. Meaning that carbon must have 4 single electron in their orbital. However, carbon just have, carbon have 2s2, 2p2. Okay, p, 1, 2, 3. So, based on this orbital, carbon just can form 2 overlap only. Overlap or 2 chemical bond, single chemical bond. Okay, but how carbon can form 4 overlapping orbital? Okay, How? So carbon must undergo hybridization to form new set of orbital. Okay. So we look at the type of hybridization. So hybridization have 5 types. First, sp hybridization. Okay, sp hybridization meaning that central atom have linear shape. Okay. Example C. Okay. Have linear shape. Example. Okay. This one. Okay. C2H2. So sp2 hybridization when central atom have trigonal planar shape. So trigonal planar example. Okay. This one is trigonal planar. Why trigonal planar? Because 1, 2, 3. Yes, it has 3 electron domain. Okay. So sp3 hybridization when central atom have tetrahedral shape. Okay, example tetrahedral shape. Okay. Okay, methane. Okay, this is the tetrahedral shape. sp3d hybridization, trigonal bipyramidal. Okay, this is when central atom have 5 electron domain. Example. Okay, example phosphorus. Okay, phosphorus Cn, 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 Cl, Cn. And sp3d2 hybridization when central atom have octahedral. Octahedral, okay, usually phosphorus, sulfur. Okay, sulfur. Okay, so these 5 type of hybridization, but in IB, okay, for chapter 4HL, higher level, we just focus on SP until SP3 only. We not go further until SP3D. Okay. So I will explain the formation of SP, SP2, SP3 hybridization. Okay. Now the formation of SP3 hybridization. Right. So central atom have tetrahedral shape. Example here I'm choosing ethane, which is H2H6, and this is the structural formula for tetrahedral shape. Okay, let's say the left carbon is central atom. This is central atom. So if have 1, 2, 3, 4 electron domain. Okay, electron domain. Okay, meaning remember that this shape is refer on the basic shape, not the molecular geometry shape. Okay, it depends on the electron domain. Electron, number of electron domain. Okay, so now, okay, which atom will undergo hybridization? Okay, remember that terminal atom. Terminal atom not undergoes hybridization. Only central atom undergoes hybridization. Yes, only central atom undergoes hybridization. So we write down the electron configuration for carbon, okay, and hydrogen. So carbon have 1s2 to s2 to p2. Hydrogen have 1s1. And diagram of orbital diagram for hydrogen is, okay, only one single electron, so it has sphere shape. Okay, now how carbon can form hybridization? Okay, if you look at the structure of carbon, ethane. Okay, carbon have to form four single electron in their orbital, but now carbon just have only 2 single electron in orbital. This is called ground state. Ground state is the original electron configuration or original orbital diagram for carbon. So, to undergo hybridization, first carbon must go to the excited state. Okay, what is excited state? Excited state when, okay, electron form 2s orbital are promote into p orbital. Okay, s orbital is low energy compared to p orbital. So this is level is called excited state because from lower energy level, it promote electron to the higher level of energy. So this stage is called excited state. Now, okay, carbon have to form hybridization orbital hybrid. How? Okay, so first take note what type of hybridization that carbon should be. Okay, carbon should be sp3 hybridization. sp3 meaning that it have 1s and 3p orbital. So just combine, okay, s and 3p orbital to form sp3. Okay, look at this orbital diagram. 1, 2, 3, 4, which is made up from 1 s orbital and 3p orbital. This is called sp3 hybrid orbital. Okay, so this is hybridized state. Okay, now how to draw the orbital diagram, 3-dimension orbital diagram. Okay, sp3. Okay, sp3. Okay, the structure, the diagram for one sp3 is draw as this. Okay, this is represent one orbital for sp3. Now it have 4. 1, 2, 3, 4. So just draw, okay, 4 sp3 orbital. Alright, so this is sp3 hybrid orbital for carbon. Okay, now how carbon can combine or overlap its orbital to hydrogen? Okay, let's withdraw the 3-dimension orbital diagram. Okay, so this is like sp3 for carbon. Okay, let's write down the orbital. Okay, note that this is sp3, 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 and then if we refer on the structure, carbon overlap with carbon. So first, make sure carbon overlap with orbital of another carbon. Okay, sp3, 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 and remember that every sp3 orbital have single electron only. Okay, first do the overlapping orbital between carbon and carbon. Next, do the overlapping orbital between carbon and hydrogen. So this is hydrogen. Okay, look at the hydrogen surrounding carbon. Okay, carbon. Okay, and let's label the orbital. This is 1s, 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 and 1s. Okay, another step is, okay, write the opposite spin of electron at the overlapping area. Okay, make sure at overlapping area have opposite spin electron pair. Okay, so now this is 3D orbital diagram. Orbital diagram for C2H6 or methane. Okay, right. Now, okay, head-on overlapping. Head-on overlapping, this part is known as pi bond. Okay, all overlapping part is pi bond. Sigma bond. Sorry, Okay, I'm sorry. Okay, this is sigma bond. Okay, sigma bond, sigma bond, sigma bond, and sigma bond. Okay, all of head-on overlapping. Okay, sometimes we call end-to-end overlapping or head-to-head overlapping, but it still have the same meaning. Okay, next. Okay, the formation of sp2 hybridization. Okay, sp2 hybridization. Okay, make sure the central atom have trigonal planar, which is 120 degree angle. Example here is 18. Okay, 18. Okay, look at, okay, let's say the left carbon is central atom. So it have 3 electron domain. 1, 2, 3. Okay. Okay, so only central atom undergoes hybridization, but terminal atom not undergoes hybridization. Okay, only central atom hybridize in orbital. Okay, so write down the electron configuration and orbital diagram for both for both atom. So hydrogen, okay, not undergoes hybridization, so still remain as original shape, which is sphere shape. But carbon have, okay, 2 single electron. Okay, now it have to form 4 single electron in each orbital. So it promote the electron from 2s to the 2p orbital. Okay, only the same energy level can promote electron. So 1s orbital cannot promote its electron. Okay, only the same level, which is 2s to 2p. Now at the excited state. Okay, at the excited state, carbon already have 4 single electron. Okay, have 1 single electron in each orbital. 1, 2, 3, 4. So to undergo hybridization, okay, carbon should be sp2 or spp. Okay, now this is the hybridization for carbon. Okay, sp2 meaning that it have 1 s orbital and 2 p orbital. So the balance orbital is called unhybridized 2p orbital. Okay, this orbital will form pi bond. Okay. Okay, the sp2 is called sp2. Okay, sp2 hybrid orbital. Okay, how to draw diagram for sp2 hybrid orbital. Okay, sp2 hybrid orbital have 3 orbital. 3 orbitals. So the diagram is, okay, 3. 1, 2, 3. So this is sp2 orbital. But now it has 1 unhybridized p orbital. So unhybridized p orbital, okay, at this part, this is 2p orbital. Remember that, okay, this is not 2 orbital but 1 orbital because p have dumbbell shape. Okay, if I draw the electron, the single electron is here. Okay, on this part, no electron. Okay, this is still considered as 2p orbital. So this is sp2 hybrid orbital for carbon. Now we draw the overlapping orbital between sp2 and s1 orbital. Okay, let's withdraw. Okay, first make sure carbon overlapping with the neighbor carbon. Okay, 1, 2, 3. 1, 2, 3. Okay, label the orbital sp2, 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 and p orbital have, okay, and carbon have 1, 2p orbital. So this is 2p orbital. Okay, p orbital, p, and sp2 orbital also combined with h orbital. Okay, not h orbital but 1s orbital from hydrogen. Okay, 1s, Okay, the next step is, okay, make sure in area overlapping orbital have one opposite spin of electron. Okay, one opposite spin of electron. Okay, how about the 2p orbital? 2p orbital will undergo sideway overlapping. Okay, this sideway overlapping will form pi bond. Head-on overlapping form sigma bond. So any head-on overlapping is sigma bond. Alright. Now this is the sp2 hybridization. Okay, this is C2H4 or ethene. Okay, hopefully you all can understand what I'm trying to explain. Okay, now we proceed to the sp hybridization. sp when central atom have linear shape. Linear example here is ethane. It have linear shape 180 degree. Okay, 180 degree, and let's say the left hand side carbon is central atom, so it have 2 electron domain, so this is linear. Now we draw the electron configuration for carbon and hydrogen. Okay, so this is electron configuration for carbon, and this is ground state for carbon. And hydrogen is terminal atom, so it still remain as the original shape, which is sphere shape. Okay, it have one single electron in each orbital. Okay, so for the carbon, from ground state become excited state because, okay, the electron from s orbital are promoted to the p orbital. Okay, now it will undergo sp hybridization. Sp, it have one s and one p orbital. So this is the orbital diagram for sp hybridization. Now, sp hybridization have two valence unhybridized orbital. This is called unhybridized 2p orbital. So if the unhybridized orbital have two single electrons, so it will form two pi bond. Okay, the left hand side sp orbital is called sp hybrid orbital. Okay, how to draw the diagram? Okay, sp have two orbitals, so the diagram is 1, 2, sp. Okay, but it have two unhybridized orbital. Okay. Okay, this is 2p, another 2p here. Okay, this is another 2p. Okay, so let's withdraw how sp hybrid orbital combined with one s orbital from hydrogen. Okay. Okay, right. So this is the structure for ethane. Okay. First, okay, carbon overlap with carbon. Now each carbon have p orbital, 2p orbital. Okay. 1p, second p. So this is 2p, 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 2p. This is sp orbital, sp, sp, sp. And okay, hydrogen will form 1s here, 1s, 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 and each overlapping area have spin orbit, spin electron. Okay, how about the 2p? 2p will form sideway overlapping. Okay, so for the first 2p orbital, combine to 2p orbital, second orbital combine to the second orbital. Okay, so we have to draw a line Okay, at the top orbital, at the bottom orbital. Okay, where is sigma bond? Okay, this is sigma bond. Sigma bond, sigma bond, sigma bond. Okay, 2p overlapping form pi bond. Okay, so that is why for ethyne, okay, C1, 2, 3, hydrogen. Okay, triple bond have one sigma bond and two pi bond. Okay. Alright, so that's all for my explanation on the formation of hybrid orbital. Thank you.